In this video, I'm going to talk about how to use a graphing calculator to solve an exponential or logarithmic equation. So first of all, I want to talk about what a logarithmic equation is, because we haven't gotten there yet. So far, we've talked about exponential equations like this, but it turns out that the inverse function of an exponential function is called a logarithmic function. So the inverse of f of x, so f inverse of x is equal to the log of x. And now the log is basically it's just the undoing function of an exponential function. So if you have 10 squared equals 100, then log base 10 of 100 equals 2. So the logarithmic equation is, the logarithm is just the opposite of it's the undoing function for the exponential function. So the important things to know are that if you just write log, logs have to have a base, just like an exponential function has a base, and the base of the exponent is the same as the base of the log. But in your calculator, you're just going to see log, which is log base 10, and you're going to see ln, which is also called natural log, which is log base e. So remember that e is that number that we talked about before. It's about equal to 2.71828. It's kind of like pi. It describes continuous growth. So the natural log is log base e, and log base 10 is just log in your calculator. And those are the ones that we'll deal with in these kinds of problems, but we'll start to deal with different kinds of logs later. But for now, you're going to, in these kinds of problems, you're going to get a couple of functions. So it'll tell you like f of x equals 2 to the, actually it says something like, it will give you like 2 to the x plus 6 equals 3x minus 4. And it's asking you to solve for x. Now, basically what you can do is you can put it into the graphing calculator as two different functions. So f1 of x is going to be 2 to the x plus 6. f2 of x is going to be 3x minus 4. And then what you're going to get is you're going to get a graph that looks like this, and then another graph that looks like this, or something like that. And then what's going to happen is you can put into the graphing calculator to find the intersection. So it's intersect is one of the tools in the graphing calculator. So you're going to press intersect, and then it's going to do that same thing that we've seen before, where it wants a lower bound and an upper bound. So just go around where it's intersecting and then hit enter, and then it will give you that value. And then you'll do the other one, because often these are going to cross in more than one place. So it would also cross here. So you'll do a new lower bound and upper bound, and then you'll use that, and then those will be the intersections, and the intersections are the place where they're equal, right? That's the place where the two functions are equal, which is the way to solve the equation. So that's a brief explanation of how to use a graphing calculator to solve an exponential or logarithmic equation. If it was a logarithmic equation, you would do the same thing. So let me get rid of a little bit here. But if you had a logarithmic equation, it might say like log 2x minus 3 equals 3x plus 6. And then you would do f1 of x is equal to log 2x minus 3, and then f2 of x equals 3x plus 6. And then again, it's going to graph those. So the logarithmic equation is going to look something like this, and then the other line is going to look something like this, or whatever. And then you'll again use those upper and lower bounds, and then the button called intersect to find those intersections, and that tells you where these two equations are equal, which is exactly what you wanted. Later on, we're going to learn how to solve these using algebra, but for now, we're going to solve them just using the graphing calculator.